My name is Iris, which is Greek for rainbow. I'm a software engineer from Austria, but I have lived kind of all over Europe, and I currently call London my home. And the reason I chose a cooking-related title for my talk is that I haven't done much else since the pandemic started. So from homemade pasta, bread, and pizza to theme nights like West Africa, Sri Lanka, Mexico, or my own ramen, I've pretty much made it all over the last year. So if you have any interesting recipes or anything from your home country that you'd like to share with me, please send them to me on Twitter. My handle's right up there. And when I don't cook, I develop products for our users at Spotify. In case you're not familiar with Spotify, we are one of the world's biggest audio streaming services with over 70 million tracks, including 2.2 million podcast titles. And with almost 350 million monthly active users, you can imagine the quality and testing practices are taken very seriously here. So let's dive right into the guidelines. Do you remember the slide? Where did I have all of these different adjectives from? Truth is, I have not spent nearly enough time in the space to come up with a comprehensive list of properties a test should have. So I instead leave that up to someone who has, like Kent Beck. In a Medium post in 2019, Kent lists 12 such properties. But what do they mean in detail? Let's look at them one by one and see how we can use them to write better tests and code in JavaScript and React. Let's start with what I believe is the most important one of all of these, and probably the only one in the list that I would never ever compromise on. Tests should inspire confidence. Confidence that your application works. Let's think about an example here. You want to refactor a central part of your application. Maybe you want to, go from state management in Redux to context API. Or maybe you want to use a script to migrate your code base from JavaScript to TypeScript. Let's not think about automated tests for a moment, but instead how you would generally go about doing like a big change like that. Would you just change the code and deploy it? At least I would be extremely careful and thoroughly test each part that I'm touching before deploying, because that manual testing is what gives me the confidence that I didn't just break the application. And that is exactly what testing is all about, inspiring that confidence and enabling you to rigorously refactor your application without fear of breaking it. And that perfectly brings me to the second point. Tests should be automated and run without human intervention. Say you work on a bigger project with several teams owning different components in your application. You now want to change a single line in the base button component that all other teams use. Not only will it take a lot of coordination from all these different teams, the testing will also have to be a joint effort, because you might be able to do the change in the button, but you don't know how it is used in all different places all over the application. And it's simply not feasible for this and any other seemingly small change to have to go through manual testing before each release, because the coordination and time effort are just too high and grow with the scale of the application as well. So if you want to enable teams to work autonomously and iterate quickly on their part of the application at a certain size, you can only achieve this through automation. Now this begs the question, when should automated tests run? The answer is basically all the time. During development, it helps to have a quick feedback loop to at least run unit tests in watch mode so that you can find bugs early before even pushing any code. Once you're ready to merge your changes, all your tests should run on that branch. Then, after merging, before deploying to production, your tests should be run on the main branch as well. This includes unit tests, integration tests, and if possible, even end-to-end tests, if you have a way of running them on this branch. And lastly, in a bigger system with many services and websites playing together, you might want to run your tests whenever upstream dependency is changing as well, because you often don't know exactly when that happens. My team opts to just run them regularly every couple of hours. You might now be wondering, isn't this impractical? Doesn't faulting deploys to run tests slow you down? This is where the next piece of advice comes in. You do not want to have to wait for half an hour for your tests to pass before you can deploy an urgent fix, or worse yet, disable test runs on important bug fixes because they take too long to run. This would remove the confidence again that we talked about earlier and makes writing tests pointless. But how do we make our tests fast? First of all, nothing says that you need to run tests sequentially. If there's one thing that will save you a ton of time running your tests, it's to run them in parallel. Then there's no need to run your entire test suite with every single change. Just rerun the test related to the files that you have actually changed or touched. You can do this in many tools. Just watch mode does it, for example. Another thing I like to do in my unit integration tests is to mock slow dependencies like network calls, animations, or anything related to timers. If you, for example, have a countdown component which renders countdown done after 2 seconds, I wouldn't sit around and wait for 2 seconds for that to happen until I can confirm it worked. Instead, I would mock the timers and run all of them. And there are also ways of making sure that it's been exactly 2 seconds. Doing this will make my tests more deterministic and faster, but I'm always careful not to mock too much because I do want to test my components like a consumer would. Lastly, another tip to make your tests faster, run them in the appropriate environment. What I mean by that is don't run tests for a utility function in a real browser, for example, but instead make use of tools like JS DOM, which are faster but a good approximation of a browser environment. Go for the fastest tool that still gives you confidence. All right, and now how do you write tests that give you confidence? Tests should be behavioral and structure insensitive. Big words. What this means to me is that I need to think about the responsibility of the thing that I'm testing. If I'm testing a function, I would call it like its consumers would. If it's a React component used by our users, I would think about how users interact with it and try to replicate that. If you avoid testing from the internals, from the component's internal perspective, and instead find ways of testing your consumer's perspective, be it a different React component or a human being, you will test the behavior of your system under test rather than the internal structure. This also means that you can now change the internal structure however you like, or refactor the component without having to ever touch the test. All of a sudden, the test actually becomes a way of ensuring that your behavior has not changed while you were working on the inner workings. Let's look at a practical example. Let's say we have a counter component which increases each time you click a button. How would you go about testing it? You could, for example, check the internal state of the button, of the counter, then call the onClick property of the button, and then check that the internal state of the counter is now incremented. If you do that, if we just change the name of the internal state from count to, say, number clicks, the test will break, all of the behavior stays the same. So what I would do personally instead is to actually check the text rendered to users, because that's the bit of behavior that we're actually interested in. So if you want to test a behavior rather than the structure of your component, don't peek into your internal state to test your logic, but instead test the resulting change in the user interface, just like a user would. And there's something else fishy with this test. We are relying on the primary button's onClick property. If we choose to render a button differently, say we use a secondary button, or the name of the onClick property changes, again, our test will fail, all the behavior will still be the same. Instead, I would opt for actually simulating a click on increment, because that is what a user would be doing as well. So don't test the behavior of your component by calling properties on React components directly. Instead, simulate the actual user behavior. Now let's look at some more properties of good tests. Tests should be deterministic, isolated, composable. But what do these words actually mean in the context of our React applications and tests? Let's start with deterministic. At the core, this means that given the same inputs, your tests will always give you the same result. There's no randomness, no flakiness. And this is great because if your tests do in fact fail at random, you can't rely on them and they won't give you that confidence that we talked about. Now, isolated, this means that your tests do not depend on one another. And if tests are in fact isolated, that results in them being composable. They can be run in any order and will always produce the same result. Tests that have these properties have two major benefits. On one hand, if the tests are isolated, so are the failures. So that makes it really easy to find out where a bug is happening. On the other hand, there is also a practical advantage. If the order doesn't matter, you can run them in parallel, which I've already mentioned is a lot faster. To summarize, all three of these properties are properties of robust tests, and they're self-sufficient and don't fail at random. And how can we achieve that? Well, one great way of making your tests more robust is by actually making the underlying code more robust in the first place. So let's look at how we can do both. One thing that will help is not changing state outside the scope of your code. If you do really have to change state outside of your scope to make tests isolated and remove dependencies between them, you will need to reset changes to the global state before and after each test. Let's look at an example. Here, for example, we have a product module which writes to a global product storage and has functions for retrieving, adding, and removing products. The first test here adds an apple and a banana, and the second test removes the apple again. This means these tests are not, in fact, isolated because the second one depends on the first one running fast. That means if you change the order, your tests will fail, making them brittle. The underlying problem, however, is not the test, it is that the functions in the products module change the global product state. To fix this, we could, for example, reset this products before each run. Or we could fix it on the side of the code. And instead of writing to this global products array, inline this state. And with that, every consumer, be it a test or your actual consumer, can create their own scoped version of the products, and the test becomes fairly simple again. Let's look at some more tips to make your tests more robust. Changing something that is outside of your scope is a side effect. So robust code in general isolates side effects, and robust tests mock those side effects and other randomness. Let's look at an example. We are here creating a component that creates a random number and then renders that random number to a user. Creating a random number is a side effect. So on the side of your code, let's isolate that. Using React, there are two great ways of isolating the side effects. We can either move this here into a property of our component or just into a utility function that we import. I'm going to do the second one. All the changes, as you see, is that the generate number, random number now comes from the outside. But this has the effect that on one hand, if we ever need a random number generator somewhere else again, we can reuse this. On the other hand, testing this becomes trivial because all of a sudden we can just look at the generate random number and mock its return value, and then make sure that we actually render that number. You can use the same trick for your business logic as well. If you extract business logic from your components into different modules, you'll make your business logic reusable and your tests more deterministic. With that, you can then also test the extracted module in isolation without having to render a component around them, which should be faster and a little bit easier. Lastly, one common source of bugs, as well as brittle tests, are race conditions, where the order in which asynchronous activities return might play a role. Make sure you wait for everything to return or test different sequences to account for this. Tests should also be specific. If a test fails, the cause of the failure should be obvious. The name of the test should already give you a good hint as to where and what might be failing. But if that doesn't help, the exact error message in the console should. And to achieve that, try to only test one specific part of the behavior of a component per test case. While this might not always be possible for integration tests or end-to-end tests, in unit tests, the setup should be quickly enough to set up several tests with a similar setup. So if we look at this, for example, rather than testing your happy path and different error scenarios all in one test case, like here on the left, if you split them out like on the right, you'll see a couple of benefits. The first one is that if you now have a failure, this here, you don't know which tests are failing. You only know that this one is failing because after that one failed, the other test cases are not being executed anymore. Whereas here on the right side, you see that other ones are still working, and it's just this one specific behavior that is failing, and that should tell you exactly where to look for your bug. Another tip that can make tests more specific is the use of specific assertions or the creation of custom matchers. Look, for example, at the two following ways of asserting an array has 3 items in it. On the top, we're checking that the length is equal to 3, and we get the error on the right, expected 3, received 2. If you now instead use the to have length assertion or a matcher, you get a lot more relevant information in the console when you get a failure. And this is just a contrived example, but using custom matchers is a great way to make your test failures more readable. And speaking of readable, that's another property of good tests. it should be really quick to comprehend a test from reading it. And reading a test should basically be like documentation for the expected behavior of a component. And how do we achieve that? Spoiler alerts, because tests are code too, it's pretty much the exact same tips as making your code more readable. Starting with the classic good naming. So use descriptive names. I like to follow the pattern of nesting components or features, and then at the end going for it does X when given Y. For example, it closes the modal when pressing the escape key. Also, keep your tests short. Just like with your code, with your other code, you can achieve that by just extracting parts of your tests into other functions or utility functions. Let's look at this, for example. On the left side and the right side, which one is more readable? Spoiler alert, they're the exact same test, just that on one example, I've already extracted a common functionality for waiting for tracking an event, whereas on the right side, that is still there. And this function can't only be reused in other parts of the test suite, it also makes the test a whole lot more readable. Lastly, make sure you use the testing library, whichever one you might be using, to its fullest to make the test more expressive and your intent clear to the reader. If we look back at this example of incrementing a counter from before, what is more expressive? Peeking into a randomly named state variable, or making sure that the headline has changed from something to something else? Similarly, what is more expressive? A line of CSS changing in the snapshot of a component, or a visual representation of that change before and after? This is why I'm not a big fan of snapshot tests and prefer using visual regression testing tools like Percy instead. And tests should not only be readable, they should also be quick and easy to write. In most cases, there's no point in spending more time writing your tests than writing your code. And while I believe that refactoring your code in a way that makes it easier to test is generally beneficial for your code base because it will make it more reusable, deterministic, and less coupled, there should always be a balance. If something is particularly hard to test, ask yourself, how important is it to be confident that this part of the application works? I would, for example, absolutely spend a lot of time writing a hacky and unreadable test, in other words, compromising on all the other properties that I've walked through already to ensure that a user can log into Spotify. But I wouldn't necessarily do the same to ensure their profile picture is aligned correctly on Internet Explorer. Another thing that often helps with this is moving up or down in the testing stack or pyramid. If something is really tricky to test in a unit test, maybe ignoring an edge case and testing the general behavior in an integration test is a good compromise. And lastly, use the right tool to write your tests. In the past, it's been extremely cumbersome to write tests for web applications, but with tools like Cypress with its visual debugger or testing library, which encourages testing from the user's perspective, there's no excuse at all not to at least have coverage for the most important flows in your application. So if the tool that you're using is holding you back, I strongly encourage you to consider switching to a different one. And now for the last one, tests should be predictive. The reason I saved this one for the end is that I think it ties everything together beautifully. We've already discussed that tests should give you confidence. This property goes a step further yet to say your test suite as a whole should be able to predict if your application works or not. If a test fails, that part of the application will fail in production. If all tests pass, the application will work in production. It is a really, really high bar to achieve this level of confidence, and we need good coverage on all fronts, be it automated integration tests, end-to-end tests, visual regression tests, whatever tests you have. But once you get to that level, the way you spend your days as an engineer changes. You'll spend a lot less time hot fixing bugs in production or monitoring your deploys to make sure they don't break the system. No longer will you be scared of deploying on Fridays or before going home. Instead, you'll be able to refactor any small or big part of your application fearlessly. And you can even start automating manual tasks like keeping dependencies up to date. As long as all tests pass, your code is suitable for production, no matter if the code was changed by you, a different team, or even a bot. And that just gives you endless possibilities. With that comes the most important change for us as developers. Without needing to extinguish fires on a weekly or even daily basis, our work becomes a lot less stressful, and we have the time to focus on what's actually important, developing delightful experiences for our users. Thank you.